Okay, this is exercise 21-25, and this one has uneven cash flows but no taxes. We've got this company that's got a special purpose bottling machine for $65,000, useful life of 4 years, and no disposal value. So it's going to get, these are the cash flows that are coming in each year. We've got a required rate of return of 18% for capital budgeting, and we're going to ignore taxes. So first would be net present value, and the only difference here is that you'll multiply it times the present value of 1 of a lump sum factor. So all the factors that you use would be less than 1 for sure. Okay, if you find yourself with multipliers in here, then you know you picked up the wrong table. So we would take each year, and this would be the value in 1 year, 2 years, 3 years, 4 years, and the total present value of the cash flows is $60,080. The investment $65,000, so the investment doesn't make it. Okay, 18% is a pretty high return. So whatever discount rate is chosen, it would make a big difference. Now payback is where you really notice uneven cash flows, and that's probably where you see problems more frequently. But we've got an additional investment of $65,000 at time 0. Then $25,000 comes in at the end of year 1. Then $22,000 at the end of year 2, and we're down to $18,000. So we don't have enough left to do a full year. So we would say that the payback period would be 2 years plus 18 over 21. Okay, that's the portion of a year. Like if you took the 21 and divided it by 12 months, that's how much you would get per month, and you could see when you would get up to this, meet that 18,000. Or just make a ratio out of it and say 18/21 times 1 year, so that would be 2.86 years would be the payback. Okay, and remember this is undiscounted, so that 18% doesn't matter. Now here is the discounted payback, and that gets more complex. A table's really the best way to do it, and this is again with 18%. Here's our time periods from 0 through year 4 and our savings, and again multiplied times the same discount rates that we use for present value. So there's our discounted savings. Now remember that the $65,000 is at time 0. Okay, that's today, so this is a present value number. So I would subtract the 21 at the end of year 1. We're at $43,825. Year 2, 28. Year 3, 15. So this is decreasing as each of the savings comes in. In year 4, 10,000. So we're down to $49,20. So the project, according to a discounted payback method, would not be worth the investment. Okay, so where it's consistent anyway, right? Yeah, for net present value, excuse me, it is not. Payback is, this doesn't really give you a decision, it just gives you some information. Internal rate of return, you'd have to fool around and figure out the number, okay? So I'm not going to do that, and you are not going to do it. It is not on the exam. If you're interested in the solution for this, I'll get it for you, but you just use trial and error to figure out what it is. And then finally, the accounting rate of return. We would take the average annual savings, excuse me, average annual savings, and the total was 88,000. Okay, so we take the 88,000 and divide it by 4 years. Our average annual savings are 22,000 per year. Okay. Depreciation would be 65,000. We don't have any salvage or disposal value there. Divided by 4, that's 16,250 a year. So 22,000 minus the depreciation, okay, would be the income statement effect would be 5750 divided by our investment of 65,000 gives us 8.85% for the accrual accounting rate of return. Okay.